Obtuse triangle, orthocenter, take 2. Now I have the correct location for the vertices that I wanted. And let's take a look at the two altitudes. Here's one thing that could be confusing. Altitudes can be in the exterior of the triangle. So what we're looking at here is this particular altitude is perpendicular to this base. So it can be necessary sometimes when explaining this to extend the side so you can see where that perpendicular. So right now I'm calling this my base and this is my altitude. For this second altitude right here, this side BA is now the base and this is my altitude, which is perpendicular. So we're going to find the equations of these two altitudes. First we're going to find the slope of the two sides for which my altitudes will be constructed. So since I want an altitude to this side, I'm going to find the slope of CA, and then I'm going to find the slope of BA. So let's do that first. The slope of CA is 9 minus negative 2 over 7 minus 17, which is 11 over negative 10. The slope of my altitude to this side will be the opposite reciprocal. And now the slope of BA, the slope is y2 minus y1, 3 minus negative 2 over x2 minus x1, negative 3 minus 17. Alright, 5 over negative 20, and that reduces to a negative 1/4. The slope of the altitude to this side will be a positive 4 over 1. Alright, let's look at these altitudes again. And I think the first equation I'm going to find will be for this altitude right here. So let's remember that the slope of this side was a negative 11 over 10. So the slope of this altitude is going to be positive 10 over 11. And now to find the equation of that, I'm also going to start with my point slope form of a line. Y minus y1 equals m times x minus x1. Let's put our slope in for m, 10 over 11. And the values for x1 and y1, when we're finding the equation of the line, are coming from point B. That's the only point that we know of that is on this altitude. So let's put negative 3 in for x1, x minus negative 3, and let's put 3 in for y1, y minus 3. And here it is. This is the slope-intercept form for this altitude. It has a slope of 10 over 11, and this y-intercept of 63 over 11 is right there. Now let's take a look at what we got again for the slope of BA. For this slope, we got a negative 1/4. So the perpendicular slope for this altitude has to be positive 4 over 1. And now when I put that into my point slope form, for y minus y1 equals, now I'm putting 4 over 1 in, 4 times x minus x1. So this is finding the equation of this altitude. To substitute in for x1 and y1, my only choice is point C. Definition of an altitude is it is perpendicular to the base going through the opposite vertex. So 7 goes for x1 right here, x minus 7, and 9 goes in for y1, y minus 9. And this is now the equation for this altitude. And remember, we had found the equation for this altitude right here. So I will be pausing here and setting up the algebra to solve this system of equations. Here are the two equations that we want to find the solution for, which means the point where they intersect. We have a few different techniques we could try. I have some other videos about solving these kind of systems of equations. But what I'm going to do first is take this first equation, and I'm going to multiply the whole thing by 11 and put the result down here. And now I've gotten rid of these denominators. I think I will substitute. Let's substitute this in for y. So that gives me 11 times 4x minus 19 equals 10x plus 63. Alright, give me a minute to solve this. Alright, distributed the 11, and now let's subtract 10x from both sides. There we go. Let's add 209 to both sides and divide both sides by 34. We have found the x value of our orthocenter, and we are almost done. We can come back to either one of our linear equations and now substitute 8 in. This one looks like it'd be easy to work with. Y equals 4 times 8 minus 19. So that's 32 minus 19. Y is 13. So let's conclude by taking this back to our graph. This is the location we're looking for, which is our orthocenter, and we can verify that we did get the correct answer with our algebra. 8, 13 is the orthocenter. Thanks for watching. Keep practicing.